8M7 lesson 5, solving equations with radicals. Okay, we're going to build on a number of building blocks from earlier in 8M7 as well as going all the way back to 8M1 for some help in solving these equations. These equations are going to look a little bit more complicated, but really they're nothing more than anything we've done so far in terms of just using our basic algebraic and geometric skills to solve problems. And I'm going to show you how to solve all 4 problem types. Kind of, I broke it down. It looks like there are about 4 problem types that are presented to you in your homework. We're going to do each one of them. I'm going to kind of teach it to you. Then we're going to go through some homework help where you will get a second opportunity to work those problems, and then I will solve them with you. So let's get going. Sorry, no glasses today. Let's get going. Okay, so let's just review kind of quickly. So when we solve a problem like x squared equals 49, so we're going to get to this point in every problem today. Almost every problem today, we're going to get to an x squared or an x cubed equals a number, and remember how we solve from there. We first of all, we have to take the square root of both sides, because the way we get from the x squared to just an x is we have to take the square root of that x squared. And when we take the square root of one side, we take the square root of the other side. Okay? So that's what we say here. We get down to x squared equals 49. We take the square root of both sides because the square root of x squared is equal to x. And then the square root of 49 asks the question, what times what is 49? And the answer is 7, because we know that 7 times 7 is 49. So we get our answer, x equals 7. So note that we are almost always talking about positive solutions in 8M7, because you might say, oh, wait a minute, Mr. Lipscomb, negative 7 times negative 7 also equals 49. But we have excluded, we're saying we don't care about negative solutions in 8M7. We don't care about negative solutions in 8M7. Okay, so that's you always have that caveat. Sometimes we'll talk about negative solutions, but not in 8M7. So the other key piece of information that we learned in our lesson 4, last lesson, was that we don't always get integers for answers. Because if we get x squared equals 12, for example, you know that the square root of x squared has got to be between 3 and 4. And we learned that whole concept last lesson, because we know the square root of 9 is 3 and the square root of 16 is 4. So the square root of 10, 11, 12, 13, 14, and 15 are all between 3 and 4. Does that make sense? We know that some number times another number, if it equals 12, it's got to be greater than 3 but less than 4. So the square root of 12 is equal to a number between 3 and 4. And because that's the first key piece of information, the second thing that we learned in lesson 4 is that you can simplify it because there is a perfect square factor hidden inside 12. So we can simplify it. Again, this is all from lesson 4. So you can break down the square root of 12 into the square root of 4 times the square root of 3. We learned this principle that the square root of a number is equal to the square root of one thing times the square root of another, that if multiplied together give you that first number. And we know the square root of 4. Square root of 4 is 2. Square root of 3 can't be simplified, so that's the square root of 3. So the square root of 12 is equal to 2 root 3. This is lesson 4 teaches simplifying radicals. All right, so let's get back on to lesson 5. And I want to review 2 key things that we need to know for lesson 5. One is these are building blocks. So the B and C are building blocks we learned about several months ago in 8M1. But I want to remind you that, or teach you, that the square root of x squared is x. That's something we've learned this in lessons 1 through 4 of 8M7. But just like the square root of x squared equals x, if you take the square root of x and then you square it, you get x. Okay, let's say that again. Or let's do an example of that. If you take the square root of 3 and you square it, you get 3. So if you take, and that would be the same thing as saying the square root of 3 times the square root of 3, right? The square root of 3 squared is the square root of 3 times the square root of 3. That equals 3. And you can use a rule that we've already learned to kind of prove that, because the square root of 3 times the square root of 3 is the square root of 3 times 3, which is the square root of 9, which is equal to 3. So you can see this isn't necessarily a proof, but it's an example to say the square root of a number squared is 3. So in other words, if you take a number and you take the square root of it and then you square it, you get the number. Just like if you take a number and you square it and then take the square root second, you get back to the number. So you can go either route. Take a number, square root it, square it, you get the number. Or if you take a number and then you square it and take the square root, you get back to the number. So that's one key thing we're going to need to know later in this lesson. The second thing is something from 8M1. There's two things. One, if you have something multiplied by something and then you square that whole thing, that's the same thing as taking that square and squaring the first thing and squaring the second thing and then multiplying them. So 2x, the whole thing squared, is the same thing as 2 squared times x squared, which is the same thing as 4x squared. Right? So you have to square the coefficient and the variable. So in this chapter, what you're going to see is like the square, or in this lesson, you're going to see if I have something like 5 times the square root of x squared, you take that squared thing and you square the first thing and you square the second. And so that's 5 squared plus the square root of x squared. Well, we just learned up here that the square root of x squared is just x, and then 5 squared is 25. We'll have some more practice with that a little later. Similarly, if you have something divided, something divided by something else and you square it, it's the same thing as squaring the first thing and dividing it by the square of the second thing. So this would be x squared over 3 squared, which is the same thing as x squared over 9. So we square the top and the bottom, right? So that's 3 squared, and that top is x squared. And we're going to be using this in some of these problems. So now let's take a look at the problem types, some of the problem types we're going to be doing, or you're going to be doing on homework today. And so I made up these 4 problems. And now the key in all 4 problems, is you're going to solve for either x squared or x cubed, and then you'll complete the problem. Okay, so we want to get this thing down to where we have x squared equals something, and then we're going to solve it. So let's do that. Well, to do that, what do we got to do first? Well, we got to do our distribution. So let's distribute. You know what? I'm going to solve these in a different color. Let's solve this in, let's solve this one in like light pink. Okay, so we're going to distribute, and then we're going to see where we get. So a half of 8x squared is a half of 8, 4x squared. Half of 4x is 2x, and a half of 20 is 10. 2 times x is 2x, and then 2 times 14 is 28. Okay, oh, well, this is working out nicely. Minus 2x minus 2x. And let's just subtract our 10 here at the same time. So this cancels, this cancels, this cancels, and I get 4x squared equals 18. Okay, let's just make this, let me just change this one really quick. Let's just pretend that this was a 15 here. Let me go back here and let's just pretend this was a 15. And the reason I'm doing this is because I don't want to introduce two concepts here at the same time. I gave a bad example, so let's just make this a 15. And let's just go ahead and whoops, let's just go ahead and change this. So that'd be 2 times 15 is 30, and so this would be a 20. This just makes the math easier, and it really highlights the example, what I'm trying to show in this example, and not make add another difficult concept that we'll get to later. So now I have 4 times x squared. So let's take 4x squared, and let's divide this by 4. And we're pretending like x squared is kind of like x, so we're solving for x squared. So now we get x squared equals 5. And now we can do what? We take the square root of both sides. So let's go up here. Let's take this up here. X squared equals 5. And let's take the square root of both sides. And if you take the square root of x squared, you get x. And that equals the square root of 5. And we cannot simplify the square root of 5 because there's no perfect squares. So we're done. Okay, so now let's go on to this one. The square root of x squared plus 4x equals 20. Well, the square root of x squared is just x, and that's what we learned. That's our building block. Right? If you take the square root of a number and then you square it, you get that original number, because the square root of x times the square root of x is just equal to x. So x plus 4x equals 20. So now let's combine like terms. 5x equals 20. Divide by 5, divide by 5, and we get x equals 4. Good. All right, now this is a problem type that we learned. We did this one. We did this in either lesson 3 or lesson 4. I forget which one, but we did this one. And basically, this is kind of like x cubed equals 27. And you say, well, if it was x cubed equals 27, you'd say, well, what times what times what equals 3? Sorry, equals 27. And the answer is 3. So this is x cubed equals 3 times 3 times 3. That's 27. 3 times 3 times 3. So x must be equal to 3. Okay, that would be the way you'd solve this one. But here you have 1 over that number. So here you get x cubed, and this is, we've solved this before, so you can go back and watch the previous lesson where I taught this, but it's 1/3 times 1/3 times 1/3. Right? You multiply all of your numerators and you get 1, and you multiply all your denominators and you get 27. And so 1/3 times 1/3 times 1/3 is 1 over 27. So when I ask the question, what times what equals 1/27th, I get, x cubed equals 1 over 27, the cube root. I say, well, what times what equals 1/27th? Well, the answer is x equals 1/3. So kind of solve it like if it was a 27, and then remember, you just got to put 1 over that because this is 1 over 27. Okay, hopefully that made sense. Now this last one, we have to use the Pythagorean theorem to find our y, because we have a right triangle, and then we're going to find the area of a triangle kind of as a bonus question. Okay, so we say this is our A, and this is our B, and this is our C. So y squared plus 6 squared equals 4 over 3 squared. And we're going to have to pull out our concept that we learned from one of our building blocks. So let's write the left side, which is easy. y squared plus 36 equals. And now this, we have to square the first thing and square the second thing. We have two things multiplied by together. 4 times the square root of 3. Well, the way that you square that is you square the first one and then square the second one. Well, the first one squared is 4 squared. And then we multiply that times the square root of 3 squared. Well, 4 squared is 16. And the square root of 3 squared is just 3. So that's 48. So y squared equals 12. Okay. So now we're going to take the square root of y squared equals the square root. Well, where did that come from? It's the square root of 12. So that's y equals the square root of 4 times the square root of 3, which is equal to 2 times the square root of 3. So y is equal to 2 times the square root of 3. So that's A, 2 times the square root of 3. Now we have to find the area of the triangle. Well, that's a half of base times height. So let's do that just a second. Let's just do that one in a different color. Half of base times height. And so that equals a half times 6 times the height. 2 root 3. So a half of 6 is 3 times 2 root 3. Well, 3 times 2 times 3 times 2 times the square root of 3 is 6 root 3 units squared. Because we don't say the units, so the area is 6 root 3 units squared. So that's our answer to B. Okay, so we're going to do some of these. I'm going to give you some homework help now, and we're going to do a number of problem types. Okay, so I'm going to let you pause and try these things. And remember, just remember our building blocks, right? Here you're going to do a distribution and then a simplification, and then you're going to solve for x squared. Over here, you're going to remember what 2 root x, if you square it, remember how we square things, and then solve. Okay, pause and try. Now I assume you're back, so let's do it. Let's do our distribution here. We get 4x squared plus 12x equals 12x plus 100. Well, we subtract 12x from both sides, and we get 4x squared equals 100. Now remember, we're trying to solve for x squared here. So to do that, we're going to divide both sides by 4, and we get x squared equals 25, and so x equals 5. Remember, we are looking only for positive roots in 8 and 7. So if you told me the answer was x equals 5 or minus 5, I would say that's okay, because I didn't tell you in this problem not to look for negative answers. But you could say, hey, Mr. Lipscomb, in 8 and 7, all we're doing is positive roots. So I just assumed that's what you meant. And I would be okay with that. Okay, so let's go over here. So this, we have to remember to apply our squared to both terms. And so we go 2 squared times square root of x squared minus 3x equals 10. So we get 4, and the square root of x squared is just x, minus 3x equals 10. Oh, well, 4x minus 3x is x equals 10. I didn't even have to do any square rooting here. I just solved the problem. Okay, let's do 2 more problems. So these ones are a little bit different, but we have a cubed and we have a, looks like we're gonna have to do one of those remembering to find the cube root, but then take the fraction. And then here we're gonna have to remember our rule about squaring quotients. Okay, so pause, this is homework. Help. Pause plus try. Okay, so you're back. Okay, so we're gonna square the top and square the bottom. So we'll get x squared over 4 squared is 16 equals 4. Now we're gonna cross multiply, right? That's like 4 over 1. And so I'm gonna get x squared equals 64. And because we're only taking positive square roots, we're gonna say, well, x equals 8. You know, x equals minus 8, okay, but we're not dealing with negative numbers. Okay, over here, you know what? We haven't given ourselves a happy cat. Let's do that. Why don't the happy cats come out? There we go. Happy cat, come out and play. All right. Okay, we're going to add 2x to both sides, which is nice because these cancel and these cancel, and I get x cubed equals 1/8. So I say, well, what times what times what? If I, you know, I'm taking the cube root of both sides, cube root. So I'm saying what times what times what? I'm not saying what times what is x, but what times what is x cubed. So the answer is x cubed equals, right? It's a half times a half times a half. Because 2 times 2 times 2 equals 8, right? If I was to find the cube root of 8, again, going back to lesson 4, that's 2 because 2 times 2 times 2 equals 8. So the answer is a half if I'm looking at the fraction 1/8. So x cubed is a half times a half times a half. So if I take the cube root of both sides, I get x equals just 1/2. Now, finally, I'm not going to leave you without a Pythagorean theorem problem. So what we're going to do here is we're going to find x, which is the height. X is the height of both triangles. And then we're going to find the area of the big triangle. Okay? Well, let's just focus on this big triangle isn't a right triangle. So let's just focus on using this triangle to find x and use our Pythagorean theorem. So this is homework help. I want you to pause plus try. And then we'll solve. So now I assume you're back. Let's solve in green just to change it up a little bit. So we have, in this triangle here, we have our A is our x squared. Our B is our 5 squared equals the square root of 29 squared. Well, x squared is x squared. 5 squared is 25. And the square root of 29 squared is 29. Right? A number, you take the square root and you square it, you get the number. So x squared is equal to 4. So x is equal to 2. And here, x can't be negative 2 because we're doing geometry. And in geometry, there's no negative distances, or there's no negative lengths. So x is 2. So the area of this triangle is equal to a half of times base times height. So A is find x. We get 2 inches. Don't forget to leave your inches off because those are our units. So then a half of base times height to get this area. And so that's equal to a half times 5 times 2, which is equal to a half times 10, which is equal to 5 inches squared. Now, is that the answer? Well, no, because that's only this side. So if this side is 5 square inches, this is also 5 square inches. So the answer is 5 square inches plus 5 square inches is 10 inches squared. And that is B. Okay, so hopefully this was a useful lesson. We did lots of little problem types here. All the type you're going to see on your homework, hopefully this is useful. We'll be on with lesson 6, where we switch it up and we talk about some different concepts for a little while before we come back to square roots and geometry and such. Leave it there, and hopefully you're loving math. Happy cat, happy math, and you'll be back tomorrow.